Hi everyone, welcome to this new lecture Fluid Mechanics. In this lecture we'll discuss a problem on laminar boundary layer flow. In our last lecture also we have solved similar kind of problems, but in that condition our velocity profile was different. For this problem, the velocity profile of laminar boundary layer is taken as small u by capital U equal to 3 by 2 into y by delta minus 1 by 2 into y by delta whole cube. So in the previous problem what we have solved in the last lecture, there the velocity profile was different, and here in this question the velocity profile is different. And here what we need to calculate, find the thickness of boundary layer. We need to calculate thickness of boundary layer, shear stress, and that is 1.5 meter from the leading edge of a plate. The plate is 2 meter long and 1.5 meter wide and is placed in water which is moving with a velocity of 200 millimeter per second. Find the total drag force on the plate if the mu for water is 0.01 poise. So this problem also similar kind of problem, only the velocity profile is given different and some data are given differently. Okay, so first of all let me write down what are the data given here in this question. So here I'll write the data given here. We can see the first of all I'll write the velocity profile. So velocity profile, here it is given the velocity profile for laminar boundary layer, which is given, this is small u by capital U equal to 3 by 2 into y by delta minus 1 by 2 y by delta q. Okay, so this is the velocity profile given, and we need to find out here, first one we need to find out the delta, that is the thickness of boundary layer. Okay, next we need to find out the shear stress. Second point, we need to find out the shear stress tau naught, and the third one we need to calculate the drag force. Okay, these are three things we need to calculate, and the data given here, these things need to be calculated. Okay, yeah, now the data given here in this question was like, first one, the distance x, we can consider distance x. How much distance is there from the leading edge, or you can say from the leading edge how much of the plate. Suppose there is a plate is present and we need to calculate the shear stress from this leading edge. This is the leading edge and this is the end part of the plate. Okay, this is the leading edge. From this point to at a distance of suppose 1.5 is there, 1.5 meter distance is there. So at that point we need to find out the shear stress. It may be like the 1.5 meter may be in this side. So just I have drawn like this, and this is the velocity profile. This is the boundary layer is there. Now the velocity profile will be like somewhere, it will be like, you know, it will be given like this. Okay, or we can take at this point also we can consider. Okay, now the distance of x from the leading edge, that is we can write, this is the value x equal to 1. This one we can write 1.5. Okay, next the length of the plate. So length of the plate L, we can write this is 2 meter, and width, that plate width is 1.5 meter. So width we can mention it, this is B, this is 1.4 meter, and the velocity of the plate which is moving with the velocity of, so that one we can write U, capital U, we can write it, this is 200 millimeter given, millimeter per second. So this one we can convert into meter per second, that is nothing but 0.2 meter per second. And the viscosity also given, so viscosity of water which is given 0.01 poise, and this one also we need to convert in terms of meter. So just to divide this 0.01 divided by 10, so we'll get here 0.001 Newton second per meter square. Okay, now for this is the velocity profile is given. Okay, for this velocity profile we need to see what are the formulas for this delta, tau naught and FD. So first I'll see the first one, the delta. So delta will be calculated, actually one formula will be is there which was derived from this equation. In the last lecture we have derived that one. So delta actually we got there. This is 4.64 into x divided by root over of RE x. This is the formula for the delta. Now we need to calculate the value of REX. So REX equal to, we know this is Reynolds number. So Reynolds number is nothing but rho U x divided by mu. So rho is 1000 and U value is already given 0.2, and this is x value is here 1.5 and divided by this is mu, that is 0.001. If you solve this one, 0.2, this is 1.5 and this is 10 to the power minus 3. Minus 3 will take it to the upper side. Just 2 into 1.5, 3. This is 30 plus 20, that means 3 lakhs. We'll get the value of Reynolds number 3 lakhs. Now just put the value in this delta equation. So we'll get delta equal to 4.64 into 1.5 and this is divided by 3 lakhs. Okay, then we'll get an equation, we get a value here, that will be our delta. Similarly, second part is what? That is tau naught, shear stress. So shear stress, this is shear stress. Actually tau naught is given, tau naught equal to, for this also one formula is there, that is 0.323 and this is mu u divided by x and root over of REX. So REX already we have calculated, so it will be easy. So let's find out the value of delta first. So first of all I'll see, this is 3 lakh, root over of 3 lakhs, 547.72. So 547.72. Okay, I'll do that one. So first 64 into 1.5 divided by 547.72, 0.0127. 0.0127. So this one we can write here. This is 0.0127. This much what meter is there. Now if you want to convert this one in terms of millimeter, also you can write this is okay. Not this is not 0 meter, millimeter means 1000 will be there. Then that is 12.7 millimeter. Okay. Now similarly here we can calculate this value. Just put the value of like 0.323 into mu value how much, 0.001 into u 0.2 and divided by 1.5 and this is root over of 3 lakhs. Okay. Now same thing, if I solve this one, this is tau naught will be we can get some, this is 547.72 something we got. Okay, let me, okay, this is 0, so 0.323 into 0.001 into 0.2 into this is 547.72 and divided by 1.5. 0. Okay, mistake it up. So this is nothing but 0.323 into 0.001 into 0.2 into how much we got? Yeah, 547.72. Yeah, divided by 1.5. 0.0235. 0.0235. So here we got the value of tau naught is 0.0235. Unit will be Newton per meter square. Okay. So this is the second value. Third value is what? Third value is given drag force. So third point need to calculate. This is drag force, FD. So FD actually we have calculated. Now see find the total drag force on the plate. Now total drag force means we need to calculate the drag force for both sides of the plate, this side as well as the down side. Now drag force what we have calculated, that is for one side only. So one side of the drag force, what we got the equation, that is nothing but 0.646 mu u, and this is root over of rho ul by mu into b. So this is nothing but Reynolds number. Okay. So anyway, we'll consider this. Actually, this is Reynolds number, but here length is different. Now length of the plate is 2 meter. Okay. So plate length is actually, this is 2 meter is there, but we have calculated this one up to 1.5 meter. Okay. So the total length is here, plate is 2 meter given. Now what we'll do, we'll just calculate this. 0.646 into mu equal to 0.001 into 0.2 is the value of velocity, and here root over of 1000, and u value is 0.2, and now length is 2 meter. So length is 2 divided by 0.001, and this is width value. Width value is already given. This is 1.4. Okay. Now we need to solve this. So yeah, so what I'll do here, I'll write this is FD equal to, first I'll multiply all this value I'll multiply, then I'll go for the square root of that. So this one 0.646 into 0.001 into 0.2 into 1.4. Okay, 0.646 into 0.001 into 0.2 into 1.4. Okay, this is the value we got here. I'll add 0.0001808. I hope this is the value 1808. Okay, now then we need to multiply root over of this value. Okay, so another one value is there, that is 1000 into 0.2 into 2 divided by 0.001. Okay, so root over of this is nothing but 632. So 632 into 0.0001 808.114. So we got here, this is something we got like 634 or something we got here, and finally we got the value, how much is there, 0.114. So now what is the force we got here, drag force 0.114, and this much Newton. Okay, this is for one side. As I told you, this is for one side. Now total drag force means we need to calculate the total drag force is nothing but let's write here, total drag force is nothing but 2 into FD. FD means the both side actually. So this is nothing but 2 into 0.114 we can write. So we'll get here, this is 0.228 Newton. Okay, so this is only for one side we have taken. Okay, this is for only one side, and this is for both side, that we can write. So this is all about the problem what we have solved. So the questions will be given in this manner, and we need to check the velocity profile actually. For as per the velocity profile, our formula will be different. So here what I have written here, this is the formula, the delta. In the previous problem, if you see, their delta value was different, and that shear stress value also, like formula is different. So based on the velocity profile, formula will be changed. Okay, so anyway, I hope you understand the problem, how to solve this. If you are having any kind of doubt regarding this, you can give a comment. Thank you all.